Hello everyone, here are the answers to exercise number 2 in Unit 5 of AC201. I'm going to be using Excel to solve this because the formulas and functions in Excel make solving for the time value of money so much easier than any other method of doing this. In our first problem, ABC Company is going to invest $15,000 into a fund which earns 8% compounded annually, and they want to know what amount that fund is going to be worth in 3 years. Second part of this question, they want to know, is that going to differ if it compounds semi-annually? What do I mean by compounding? Well, if it compounds annually, we get interest every 12 months. If it compounds semi-annually, semi means half, which means we get interest every 6 months. And that interest sits into our investment, and we earn interest on top of interest, which is compound interest. That's why they call it compounding. Let's start with the first question we have here, which is what amount of money will be in that fund in 3 years if we invested and it compounds annually. Well, to solve this, we can use the functions, which is this little FX button right here, and we hit it, and we need one that is going to make sense here. Well, we know what we're putting in today. We want to figure out what we're putting in the future, so we're going to use the FV function, or the future value function. And this screen pops up and it asks us to input a whole bunch of function arguments, one of which is the rate. Well, we have this. Our rate is 8%. N per is the number of compounds that we're going to have. It compounds once a year. We're going to invest it for 3 years. So we're going to have 3 compounds over its life. Payment is used for a series of payments. Well, we're not doing a series. We're putting $15,000 in today, so we're going to leave that blank. Present value is used when you put a one lump sum amount in, which is exactly what we're doing. It is for $15,000. And since we're paying it out, I'm going to make that number negative. And then lastly, the type section is for annuities. And you fill in here if it happens at the beginning of the period or the end of the period where we're doing a lump sum. We don't need to worry about that right now. So we're going to hit OK. And it's going to tell us that we put $15,000 into a fund which earns 8% and compounds annually. In 3 years, that fund is going to be worth $18,895.68. Well, what happens if it compounds semi-annually? We're going to go back and use the same FV function. In this case, we have rate. Now, the rate is how much interest we get every time it compounds. The 8% we have is for the year. Interest rates have to be expressed in terms of annual percentages. They call them APR. It makes it easier for people to determine which investment they want to be in. Well, if we're getting 8% in total for the year, and it compounds twice during the year, we're going to get half of that each time it compounds. So let's fill in 4%. N per is the number of times interest is going to compound on this investment. It compounds semi-annually, twice a year. And it's going to do so for 3 years. 2 times 3 tells us that it's going to compound 6 times over the life of this investment. And then again, the amount that we're putting in today is $15,000. Let's make that number negative. And that comes out to be $18,979.79. You see that is higher than it would be with annual compounding. Always true. The more frequently an investment compounds, the more of a return you get if everything else is equal. The overall annual rate, the length of time you have it in there, and how much you invest. In question 2, we have that if ABC Company needs $25,000 in 4 years, what amount must they invest today into an investment which earns 12% compounded annually? And what amount would they invest in this investment instead earn 12% compounded quarterly? Let's start with annually. We know what we need in the future. We need $25,000 4 years from now. What do we have to put in today? Well, we need to figure out a present value. So now we're going to use the PV function. We have the same arguments here. The rate is the rate of interest every time it compounds. Well, we have a 12% investment compounded annually once a year, which means the one time a year that it compounds, we're going to get 12% interest. Number of periods. How many times it compounds over the life of the investment? Well, if it compounds once a year and we're investing for 4 years, it's going to compound 4 times. Payment, again, we don't need. We're putting in one lump sum today. So that is going to be what we're looking for. It's not an annuity. There's not a series of payments. What we do have right here is the future value that we need, though. We need to have $25,000. Now let's again make that negative. We get $15,887.95. If we put in $15,887.95 into this investment today, we let it sit there and earn interest on top of interest. It's going to be worth $25,000 4 years from now. Well, what's the difference if this compounds quarterly? We're going to use the same function. We're going to use the PV function. But our inputs are going to change. Now, the rate is 12% per year. But if it compounds quarterly, it compounds 4 times a year. How much is that each time it compounds? Well, if we got to spread 12% over 4 different times, take 12, divide it by 4, we get 3% each time. The NPER, the number of times it's going to compound over its life, is a 4-year investment that compounds 4 times a year. If it compounds 4 times a year for 4 years, it'll compound 16 times in total. And again, the future value that we need is $25,000. If it compounds quarterly, we only need to put in $15,579.17. Again, why? The more frequent the compounds, everything else being equal, the greater your return is going to be. So we need to put in less in order to get to that same amount. In our third question, XYZ Company is planning to invest $8,000 per year for 20 years into a fund which will earn 6% annual interest. What amount will be in the fund after 20 years if XYZ makes its first payment at the beginning of the year? And what amount will be in the fund after 20 years if XYZ makes its first payment at year's end? I'm actually going to do the second part of this first, the at year's end. How are we going to figure this out? Well, we're putting an amount of money in, and we're putting it in each year for the next 20 years. It's the same amount, it's $8,000. We're putting it in at the beginning of each year, so it's in regular intervals. That is by definition an annuity. We're trying to figure out what that series of payments that we start making today is going to be worth in the future. So we're going to use the future value function. And for this future value function, what's our interest going to be? Well, our information tells us that it earns 6% annually. So let's put in 6%. Number of periods is how many times it's going to compound. Well, if we're earning 6% a year for 20 years, it's going to compound 20 times. And the present value is for a lump sum. This isn't a lump sum, right? We're putting in $8,000 per year for the next 20 years, which means that is a series of payments. Let's make that negative. And it tells us that if we put in one more zero, if we put in $8,000 a year for the next 20 years, earning 6% annual interest, the fund will be worth $294,284.73 at the end of those 20 years. Well, what happens if we do this at the beginning of the year instead? Well, if we do it at the beginning of the year, we get that one extra compound, right? Because the money is sitting in there in the first year. Like if we make the investment on January 1st of the first year we deposit, we get that first year's interest. If we wait till December 31st, we don't, because the year is over. We don't earn the interest. So all you do to answer this is you take the future value of an ordinary annuity and you multiply it one more time by 1 plus rate. So we take our $294,284.73 and we multiply it by 1 plus rate. Our rate is 6%, so let's multiply it by 1.06. And that tells us, once I expand this a little bit, that we're going to have $311,941.81 in if we make our first deposit today, because we get that extra year of interest. In question 4, XYZ Company needs $250,000 for plant expansion and we need it 10 years from now. How much must they invest at the end of each year into a fund earning 5% to have the funds necessary in time? Okay, so what are we figuring out now? We know what we have to have in the future. We know the rate. We're not making a single payment. We're trying to figure out how much we have to invest at the end of each year. So we're trying to figure out what the payments are that we're going to have to make into this annuity to come up with the future value we want at the end. Well, in Excel, you can figure that out by using the payment function, which is PMT. So if we go to payment, it gives us the same inputs. First, we start with the rate. Well, we know in this case that the fund is going to earn 5% each year. So let's make the rate 5%. The number of periods is how many times we're going to make these equal deposits. We're going to make an equal investment at the end of each year. For the next 10 years, we're going to make 10 deposits, if you will. And the future value that we need to come up with is $250,000. That's what we got to have. So let's make that negative 250,000. And that information tells us that if we make a deposit of $19,876.14 on the last day of each year, 10 years from this date, we will have $250,000 in our investment fund. Question 5, let's take it away from the bigger business aspect of it, and we'll make it a little more personal. Leon Tyler's Visa balance is $793.15. He may pay it off in 12 equal end-of-month payments of $75. That's the deal Visa has given him. Well, what does the rate have to be on his card? Well, what are we trying to solve for here? We have the present value of the payments that we're making, $75 a piece. We have the number of periods, it's 12 months, and we have the future value, $793.15. What we don't have is the rate. So Excel has the rate function. So let's go to rate. In this case, we're going to start with the NPER, the number of periods. We are making these payments for a series of 12 months. Each payment that we make is going to be for $75. Let's make that negative. And the present value of our debt, what is presently on our balance, is $793.15. And we find that the rate on Leon Tyler's Visa card is about 2% per month, or 24% per year. Next up, Maria Alvarez has invested $300,000 into a fund that earns 4% interest compounded annually. What equal amounts can she withdraw at the end of each of the next 20 years? So essentially what we're finding here is this is how much money she has sitting around. It's sitting in a fund that earns this. How much can she take out so that the fund is not empty for the next 20 years? And your natural instinct here is to say, well, 300,000 divided by 20 means $15,000 a year. That just makes sense. But then you're not accounting for all the interest that is going to earn on what's still in there. So what are we going to do to solve this? We're trying to figure out what that regular series of amounts that we can take out is, and that is the payment function that we use for annuities. So the rates that it earns is 4% interest compounded annually. The number of periods. How many times does she want? Let me move this over so we can actually read what's going on here. There we go. How many times down here does she want to withdraw? She wants to withdraw at the end of each year for the next 20 years. And what is the present value of the amount that's in the fund? It's 300,000. Let's make it negative. She can withdraw $22,074.53 each year from that fund. And by the time 20 years passes, if she keeps withdrawing at that rate and it keeps earning 4% interest, the fund won't go broke until the end of those 20 years. Next up, we have Clancy Incorporated. They're going to issue $2 million of 7% bonds due in 10 years with interest payable at year's end. The current market rate of interest for bonds of similar risk is 8%. And right there we have a problem for Clancy. Their bonds don't pay as much interest as other bonds from companies that are of similar risk. Well, if we go to sell those for $2 million, no one's going to buy them because they could just buy the 8% bonds instead and get better interest. So what do we got to do? We have to offer these at a discount. So we got to figure out what amount we can sell these for that we'll receive at the time for our bonds that aren't competitive, I guess, with other bonds as far as interest rates go. We got to figure out two things here. Again, how bonds work is we're going to sell these, 10 years are going to pass, and then we're going to have to pay back the $2 million. That's the principal. That's one lump sum coming 10 years in the future. So since it's in the future and we know the rate and we know how much time, what we have to figure out is what it's worth in the present. So we're going to use the PV function. What are our inputs here? Well, these bonds pay 8% is the current market rate, and we're going to discount at the current market rate, so 8%. The number of periods, the number of years until that $2 million is due is 10 years. There is no payments because it's just the one big large repayment of principal. And the amount of principal we're going to have to repay, even though we're probably going to sell these for less than $2 million, we still got to pay back the $2 million at the end. Which means that principal is worth $926,386.98. Yeah, it's $2 million, but you got to wait 10 years to get that $2 million. So it's not worth $2 million to you today. What about that series of interest payments that we're going to have? Well, again, that is still going to be the present value because those payments are coming in the future. We know what the rate on them is. We know how many times we have to pay interest. The rate that we have to discount by, again, is always not what our bonds offer, but what the market rate is, which is 8%. The number of periods we're going to have to pay interest, I'm assuming here, 10 times. What is the amount of interest we have to pay out every year? Well, we know that our bonds are going to pay 7%. 7% of what? 7% of face value of $2 million. So let's go and take negative $2 million and multiply it by 0.07, or that's 7%. Which means the present value of that interest is $939,411.40. Let's add those two together. And we come up with the present value of a bond of $1,865,798.37. Again, because our bonds pay less interest than those of our competitors, we can't sell them at face value. We have to encourage people to buy our bonds, which means we have to issue them at a discount. In question 8, ABC Company is going to settle a $20,000 loan due today by making 6 equal annual payments of $4,727.53. This is going to happen at the end of this upcoming year. We need to determine what interest rate we're getting, because if you do the math real fast here, 6 payments times $4,727.53 is a whole lot more than $20,000. So we're getting charged interest still on this repayment schedule. What amount of interest? Well, we're determining a rate. So let's use the rate function. And in the rate function, we're going to start with our number of periods. How many payments are we going to make? We're making 6 equal annual payments. So our NPER can be 6. What is our payment? What is the amount that we are transferring at the end of the next 6 years? It is this, $4,727.53. And since we're paying it out, it's going down for our company, we're going to make that negative. What is our next input? Well, our next input is the present value, right? We owed $20,000 today. That was the current amount of our debt. So let's throw that $20,000 in, and then we hit OK, and it tells us the rate of interest that we are getting charged on this debt restructure is 11%. So essentially, instead of paying a big lump sum of $20,000 today, we're going to defer repaying it and pay it back in smaller payments, but by doing so, we're going to have to pay more. How much more? 11% more annually. Next up, in question 9, ABC Company's creditor would like the first payment on this loan today instead. So we got to wait to the end of the year in question 8. Now we have to make a payment at the beginning of the year, which means our series of payments is no longer ordinary. It is an annuity due. We're going to assume that the rate is still the 11% that we found above. What amount must ABC Company make for each equal payment? Well, let's figure this out. What is the present value of the annuity due? It's still $20,000, right? Because that's what we owe today. So we can just type that in. As the present value is our current amount of debt. What amount of payments must we make here? Well, how are we going to solve that? What amount of payments? Sure sounds like the payment function. And we go to the payment function. And we get our rate, which is still 11%. N per is the number of periods that we have to pay for. And we're still making these payments 6 times equally, but we're just starting at the beginning of the year instead of the end of the year. And the present value that we have is still 20,000. How do I make this different than what we just solved for beforehand? Well, the difference is now that the series of payments are happening at the beginning of the period, it becomes an annuity due. And if we click and type, it tells us if payment is the beginning of the period, we want to input 1. If it isn't, and why I haven't been using it so far, is that if it's the end of the period, we can either hit 0 or we can leave it omitted while we're making it at the beginning. So let's put a 1 into our type to tell Excel that this is in fact an annuity due. And if we do so, we come up with $4,259.04, which is cheaper than that $4,727-ish dollar payment we had in step 8. Why is it cheaper? Because we're giving them something today. And lastly, in question 10, XYZ Company has $10,000 in free cash flow to invest in an account which earns 9% annual interest, and the company wants to use this to finance a minor building remodel which is going to cost $17,100. How many years must this investment sit in the account before we have that necessary funds? So how long is it going to take $10,000 to turn into $17,100 if the account we invest in earns 5%? We know the present value, 10 grand. We know the future value we need, 17,100. We even know our interest rate, which is 5% annually. We got to solve for time. We got to solve for the number of times that this interest has to compound to get us from our present value to our future value. In Excel lingo, we are going to solve for the number of periods. That is the N per function. Well, what do we input here? First thing first, what's our rate? It's 5% compounded annually or once a year, so it's 5% each time it compounds. Next up, we don't need a payment. We do have the present value. We know that. That was 10,000. And we know it's got to turn into $17,100. Well, if we go and we put this into our answer over here, it tells us it's going to take approximately 11 years for that amount of money to turn into $17,100.